What's going on, simplifiers? Welcome back to Dennis Simplifies. In today's video, we are going to go through the Runge-Kuttas of the ordinary differential equation single steps in numerical methods. So sit back, relax, and as you already know, let's simplify. So we have been given the question before. So this is we using a different method to solve the same problem. So in the previous video, we were using the other method, which is the earliest method to solve this same problem. And then we realized that our final solution was quite far from the absolute or the exact solution. So the margin of error or the absolute error was quite big. Now in this video, we want to try the fourth order Runge-Kutta's method to see if this will be quite, very close to the actual solution. So let's get to it. So over here, we've been given the range again from 0 to 0.6. We've been doing this before, and then we said the step length is 0.2. From the previous video, you will know from this, okay? And then we have the main equation here. We said that with their single steps, initially we've been dealing with polynomial equations, but when it comes to this one, we are now dealing with differential equations. Okay, so ODE, ordinary differential equations, and we've been given the initial value of y, which is y naught to be 1. Okay, so from here, from our interval and then our step length, we can construct our table. So from here, we say that the step length is equal to 0.2, and then our x values are going to start from 0. So 0 plus 0.2 plus 0.2 plus 0.2, and then we end at 0.6. Okay, so that will be our x values. Now we know that our first y value is equal to 1. From the question, you say y naught or y0 is equal to 1 over here. Now the job here is now to find the values for y1, y2, and then y3 using the Runge-Kutta's fourth order scheme. Alright, so this is how the Runge-Kutta formula actually looks like. So we have yi plus 1 equals yi plus 1 on 6 multiplying k1 plus 2k2 plus 2k3 plus k4. Alright, now these k values are actually defined. So the k values are equal to each function of xi, yi, and then k2, and we have the k1 inside the k2 over here. Then when you get to the k3, you have the k2 inside over here. And then when you get to the k4, you have the k3 also in there. So you can see that they actually follow each other, right? So you can't get one wrong. It affects, they actually affect each other. So the K1 is in the K2, and the K2 is in the K3, and the K3 is in the K4, right? So make sure that you have everything arranged in order. So now that we have defined our K values from this formula, you can also see that we have our X and Y values also not defined here. So if you go back to the formula that we have, the equation that we were given, which is Y times the Y prime equals X, we can make the Y prime the subject from the equation. As you said, we are solving for differential equations, okay? So when we make y prime the subject, we are going to get a f of x. So f of xy equals x over y, or x on y. So we are bringing this y down here. So you have x on y over here. All right. So from this one, we can actually get to define this function over here. So you go there. We have f xi yi equals xi yi, right? So this is where we are actually, so we have actually defined all this over here. So to get our functions here, all we'll be doing is that we'll be taking our x values and be dividing them by the y values. Okay, all right. So now let's go ahead and start our iterations and then solve for our y values. That is our y1, y2, and then y3 values. So now let's go ahead there and then let's start. So for our first iteration, that is finding for y1. Okay, so we can define the equation again. So this is the main equation I've placed on top here. So for yi or y1, we're going to get, we are starting from 0. Okay, so when I is equal to 0, we are having y0 plus 1 on 6, then k1 plus 2k2 plus 2k3 plus k4. All right, so the next thing to do now is to define these key values or find our key values. So you're going to start from the K1, K2, K3, K4. You're going to find for all these values. So we already have the equations already. So say K1 is equal to f x naught y naught. Right, these are the zeros. Okay, so from the formula here, we are starting I from 0, so 0 0, and then we know that h is equal to 0.2. So we are finding for the f of x naught y naught here. Right, and we said that to find them is just the division of them. So the x value divided by the y value. we know that the x naught is actually 0 from the table, and then the yi or the y naught value is also 1 from the table here. So we're getting 0.2 multiplying this value giving us 0. So we have finally found our k1 value. So we can move on to find our k2 value. Now for the k2 value too, we have found for k1. So we put a k1 inside the formula here. Then we know x naught, we know the value for h. So we can simplify that to get to 0.2, then the function of these two values over here. So we simplify these two values here, then we divide them to find the value for k2. So the same thing, we simplify it to get 0.1 and then 1. Then we use this formula here to find for 0.2 and then this, and then finally we get our k2 value. Now next is to find our k3 value. So for k3 to also has a formula, we have the value for k2, we know x naught and we know h. We also know for the value for y naught. So we simplify that over here, we put the values inside here. Then again we simplify these two values here, right? So that we get a main function. Then we get 0.2, the function of this 0.1, and then this 1.01. Then we divide them according to the formula that we have over here. Then when we do our multiplications, we get our k3 value to be 0.02. Okay. Then next to find the value for k4. So for k4 too, this is the formula that we have. We have k3 inside of it. So we put the values inside there. Then we simplify to get 0.2, the function of these two values, which is 0.2 and then 1.02. Then we divide them and multiply it by 0.2. So when we do that, we get our k4 value now to be 0.04. All right, so like I can see that we have found our values for k1, k2, k3, and then k4, and we also know for y naught. That means we can find the value for y1. All right, so when you put the values inside, we put the values that we just found inside, we can finally say that the y1 value that we are getting is now 1.02. So we can put the value inside our table here that finally our y1 value is 1.02. Okay, so now the next thing to do is to find the value for y2. So you move on to the second iteration, that is when I is equal to 1. All right, so you move on there. Then when I is equal to 1, we are going to get this y here to be y is equal to 2. Then here is going to be 1 plus 1 on 6. Then we have our k values here. So again, we go through the same process again by finding for all our k values. That's k1, k2, k3, and then k4. So again, to find for k1, we are using x1 and then y1. Note that. So from here, we know saying that when I is equal to 1. So we are finding for when x is x1 and then y1. Okay. Then now we divide the two values and multiply by the h. Then we get our k value to be 0.04. Now we can find our x1 value from the table. X1 is 0.2, right? And then from our previous one, we found that the y1 was 1.02 from our previous iteration. Then we find our k value. Then again, we're going to find the value for k2. So this is the formula for the k2. Again, we have h, and then for inside here, we know the value for h, we know the value for x1. So x1 is 0.2. We put it inside over here. Then we have to simplify this big bracket here. So when you do that, you're going to get 0.3 and then 1.04. Right? So within this function, what we do is that we divide it according to the formula we have on top here. We divide them and then multiply by the h value, which is 0.2. And then we have our k2 value, which is 0.06. Then we move again to find our k3 value. So the k3 value is also hf. This is the formula that's given. We put in our h and k2 and y1 values inside. We put them inside, then we simplify this big bracket here to get 0.3, 1.05. Then what we do next is we divide the two of them and multiply it by the 0.2, which is the h value. Then we get our k3 value to be 0.06. Right? Now the next thing to do is to find our k4 value. So for the k4 value, to use the formula that we have, so we put in our x1 value, h value, y1, and then k3 values from our previous iterations. Then we simplify to get this f of 0.4, 1.08. Then we divide them according to this one here. Then we multiply by the 0.2. Then we finally have our k4 value. Right? Now with our k4 value, we have our k1, k2, k3, and k4 values. So now we can finally find our y2 value here. So we put the values inside the y2 formula. We have our k1, k2, k3, k4. We put them inside here. We know the value for y1 from our previous iterations. We add them up and we have the y2 value to be 1.079. All right. So now the last thing to do now is to find for our y3 value. Okay, so that will be our third iteration. So for our third iteration also, this is the formula that we'll be using. So we said when I is equal to 2, so we put the I equals 2 over here. From the formula, for the main formula, here is going to be 3. When I say I is equal to 2, so here will be 3, and then here is going to be 2. And then the k value. So again, we are going to find for our k value starting from k1. This is the formula for the k1. Now we are saying that I is equal to 2. So you have to have x2 and then y2, right? X2 from the table here is 0.4, and then y2 is 1.079 from our previous iteration, right? So we divide them and we multiply by the 0.2. We divide according to this one and multiply by the 0.2, and then we have our k1 value here, right? Next is to find for our k2 value. Again, for the k2 value, this is the formula that we had. We know for x2, we know h, we know y2, and we know for k1. So you put the values inside the formula here, and then this is our f. So we do the division. We simplify this portion here and then this portion over here. We get a 0.5 and a 1.116. Then we divide them according to this one here, and then we multiply it and then we get 0.09, right? So this will be our k2 value. Then next is to find our k3 value. This is the formula for our K3 value. We know for X2 to be 0.4, we know H to be 0.2, we know K2, we know Y2 from our previous iterations, right? So we put them inside the formula, alright? Then when we have our F value here, we simplify this part, and then put it inside the bracket here. Then for here, we come here for the F value that we have, and then we divide them according to this one. Then when we divide, we multiply by the 0.2, and then we have our k3 value, right? Now the last thing again is to find for our k4 value. For the k4 value, this is our formula, right? We know the h, and then we know x2, we know h, we know y2, we know k3. So put the values inside there from our previous iteration, put the values inside. Then we simplify this part here to get 0.6. Then we simplify this part here to get 1.168. Then next thing to multiply by the 0.2. So when we do that, we're going to get our k4 value to be 0.103, right? So now we have found for our k1, k2, k3, and k4 values, and we know our value for y2. So that means that we can find the value for this y3 here, right? So when we do that, we put it inside the formula, put the values inside here, and then we have our y3 value to be 1.168. So now we have found for all the values inside our table. So now let's check whether the Runge-Kutta's answers are actually close to the actual solutions that we know of. Right, so we have y1, y2, and y3. So as we said, our y1 value was 1.02. You can put it inside the formula here. Our y2 value was 1.079. You can put it here also. Then the y3 value is 1.168, which you can put over here as well. Alright, so now from our previous video, when we solved this equation here, when you find the integral of this one and then you solve for it, finding the value at x equals 0.6, the equation was y equals the square root of x plus 1. When you put the x equals 0.6 inside that equation, we had the answer to be 1.167. Now from the Runge-Kutta's method, when x was equal to 0.6, which is 0.6 over here, we had the y3 value to be 1.168. So you can actually see that the Runge-Kutta's method has its values very close to the original solution, which is the 1.167. You can see that it's very, very close to it. So you can see that this Runge-Kutta's method is better than the other methods which we have been studying, like the Euler method, the all the other methods, right? So you can see that comparing the absolute error, we may conclude that the fourth order Runge-Kutta scheme gives a more approximate solution than the other single step schemes, right? So you can see that the absolute error is very, very small, and the Runge-Kutta is giving us a very, very good answer. So friends, that's basically it for the Runge-Kutta's method for the ordinary differential equations. Don't forget to like, share, leave a comment. If you have any questions, be sure to leave them in the comment section. I'll be willing to reply. And then see you in the next video. Until next time, Apatia.